So we keep solving our physics GRE 93. This question is easy. So it looks very deep. It looks very long, but it's easy. So it said a parallel plate capacitor has a plate separation D, and there's a voltage. And the electric field is E and the mu naught. And after that, there's a capacitance. There's a dielectric constant kappa object which fill the empty region, and ask about the change of the electric field and the inner electrostatic energy. Okay, so one important thing is that you need to know that the electric field from here to here times the distance must be the V naught, because basically this is the definition of the potential. The definition for the potential is the electric field times the distance, or basically electric field do the line integration. So let me electric field is still the same. So the answer should be A, B, C, one of them. And another formula you need to remember is in the electrostatic, this energy is basically this epsilon half epsilon electric field square. So this is the energy per volume. Energy per volume. So basically the changes from epsilon naught to kappa epsilon naught. This is the only change because the electric field is the same. So the energy is just from the mu naught to k kappa mu naught. So the answer is B. The answer is B. Okay, I think 94 is the most difficult question in this problem set. Okay, so basically you have two. You have a midway. You have a row which x from 0 to 10, and then there's O prime. There's O, and from the O perspective, you know that you see that two of lights shine together. And for some strange O prime, he sees that one of I can assume maybe this one or this one, but one of its like flashes 13 nanoseconds, and which is the speed of this one. Okay, so there are 4 Lorentz transformation equation, but we only need one of them. We need the time of them. Okay, so I denoted this event to be the first event. This is second event. So from the first event, we have since first event and second event are simultaneously, so I can denote this exit t is 0. Okay, so we have some t prime which we don't know. It's gamma x0 minus v divided by c squared 0, because this is x is 0, so t prime 0. Some t double prime which we don't know, gamma t is 0, and v over c squared is some 10, which is we don't know. But okay, so we just write it down because we don't know what is this. But somebody tell you that the t prime and t differ around 13 nanoseconds. So this tell you that the 13 nanoseconds, so we change is 10 divided by c squared v times gamma. So by the way, this gamma is 1 over v squared over c squared. Okay, nice. So you can solve it. To solve it easily, we will let v over c to be beta. So this equation can be changed as 13 times negative 9 times c divided by 10 is equal to since 10 goes to here and c goes to there, so there will be remaining v over c. So this one. Okay, so we have beta, and the c is 3 times 10 to the 8, so we have beta minus divided by 1 of beta squared is 0.39. Okay, So we solve beta. Okay, so we first did square. We get beta square equals to 0.39 square, 0.39 square beta square. So we have beta equals to 0.39 square 1 plus 0.39 square root c. Okay, so you need to find this. Basically, it depends. There are many ways to do, but this is the answer. So the answer is 0.363. So the answer is C. The answer is C. Okay, so I think it's enough for these two, and we will keep the remaining only 6 questions, and we will try to solve the subject physics GRE. And I will see you guys in the next video.